to work out day 17. Part 1, let's look. There's part 1, part 2, and then there's a part 3 that's down here. So let's read part 1. Print the integer maximum value using the built-in constant integer max value. Okay, I'm going to copy that so I don't have to type it again. Right here, system.out.println integer max value. So that's pretty easy. And then I want an integer min value, and I want double max value, and I want double min value. So I'm going to do min value. In fact, I'm going to redo this copy. Less typing, and this is going to be capital D double. This will be capital D double. So what we're getting here is integer max value, integer min value, double max value, double min value. Let's run it. That'll be part 1. I just wanted you to type those in things out and kind of reinforce that there's limits to things. The doubles are just absolutely huge. This is a 1 with 308 zeros after it. So that's a very, 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 very large number. And this is a 4.9 with, it's 0 point and then 324 zeros before you get to the 4.9. So very, very small number. Okay, part 2. Create a scanner, ask the user to enter a password, save it in a string variable. We can do this. System, let's make it a scanner. Scanner, scan equals new. Please enter a new password. So string password equals scan.next line. And then I ask you to ask them to re-enter the password, saving it in a different variable, and then we're going to do some comparisons. So back to here, I'm going to just copy these 2 lines. Please re-enter the password. I'm going to line those up, and I'm going to call this password 2. Now that I'm thinking of it, I'm going to call it password 1. Password 2, okay. And then I ask you to print the result of comparing them using double equals and then using dot equals, and make it clear what the output is. So right here it says comparison using double equals false, comparison using dot equals true. So that's part of the assignment. System.out.println comparing using double equals right here. And in parentheses, we're going to say password 1 equal password 2. And then we're going to do comparison using dot equals. And I'm going to move this out because I wanted the results to line up. And this is going to be, instead of double equals, we're going to do dot equals. I'm sure to add that. So let's go ahead. We're not done, but we're making great progress. Please enter a password. Hamster. I'm going to re-enter it. Hamster. Now you would think they would both be equal, but when you compare those two with double equals, it says false because you don't compare strings using double equals. You use dot equals when you're comparing strings. So we're almost done with that. Make it clear. Great. Use an if-else statement using dot equals to report if the 2 entries are the same or not. So then I'm just asking you to one more time. If password 1 dot equals password 2 out.println the 2 are equal. Else system.out.println the 2 are different. We'll run this and I'll make them so they're not the same this time, just so we have another test. I guess I forgot a semicolon. Joke. I was going to try to make them not equal, but I forgot to do that. So it did work correctly for what I entered. Here's a password, and there's another password, and the two are different. Okay, and then part 3 is a totally different beast. We've got a method right up here that I want you to write right here, and it's the fraction method should return valid if n divided by d makes a fraction that's greater than or equal to 2, and invalid if it does not. So I'd like you to read the full instructions because I'm asking you to make a single compound Boolean condition, and you're going to have to use short circuit logic. I'll show you why that's the case. If we just do this, if n divided by d greater than or equal to 2, return valid, else return invalid. See if you can think of why this won't work. We'll see why. We got an arithmetic exception, divide by 0. And that's because sometimes d is 0. Given the data set that I created here in my test code, I intentionally have made some of the denominators equal to 0. And so we can make this, we can use short circuit evaluation to make this still very easy to do. You could just write another if statement, if d is not equal to 0, and put this other code inside of it, but I want you to do it as a single if statement. And so all we have to do here is say d not equal to 0 and what happens is Java uses short circuit evaluation. If d is equal to 0, it doesn't even go and evaluate the second part of the if statement. It just goes to the invalid. That's what short circuit evaluation does. So, and so here we go. We're getting invalid whenever the fraction either has a 0 on the bottom or is less than 2. So here's 2 divided by 2, but 3 divided by 1, yeah, that's valid. Okay, so I know it was a lot of talk for a very simple line, but I wanted you to see in person, if you took off this part, this code will crash because it ends up trying to divide by 0. And yes, you could write an if statement. We could write if d not equal to 0, and then put this whole other thing inside the quotation, but it's actually a lot easier just to put it right here, d not equal to 0, and knowing how short circuit evaluation works, if this is not true, then it doesn't even bother to check this side because it's an and condition. So it knows, hey, it's not going to work. They're not both true if the first one's false. So I'm not even going to test the second half. I'm going to go ahead and return invalid. So I'm going to just run it again, make sure I didn't break it. Friday, the two are equal, and we've got invalid, and everything's great. There we go.